All right, good morning, everyone. It's 8 o'clock, so we'll go ahead and get started. This is how we will run the Zoom session. So I'll start out by going over the course materials for the week. And this week is really about Boolean expressions and conditional execution and test reports. And then towards the end, I'll talk about the assignment and kind of give some example that should help you do the assignment. It won't be exactly what your assignment is. I'm not going to give out the answers to the homeworks, but we'll do an example that's similar to your assignment. So you can probably just take it and expand upon it to complete the assignment. And then at the end, we'll have a question and answer session where really you can ask any question you want about the course or Python in general. And of course, during the instruction, if at any time you don't understand something I'm talking about, or if you just want to ask a question, feel free to just go ahead and ask the question or put it in the chat box. If you put it in the chat box, I may not notice it immediately, but I will see it. But of course, you could also unmute your mic and ask your question. I want to let you know that these sessions are recorded. So if you're not able to attend this morning, or if you have to cut out a little bit early, the session is recorded and it will be posted online a little bit later today, and then I'll email out the link to the class so that you can watch it again later if you need to review any kind of material. All right, so let's get started. So the first thing we're going to talk about is Boolean expressions. Boolean just means whether something is true or something is false. That's all Boolean means. So what do we mean by true and false? Well, obviously true means something's true, and false means something is not true. So what is that something? Well, first let's talk about true and false. True and false are two keywords in Python that just means that. This is true and this is false. So what that looks like, let's print out true and let's print out false. Oops. Let's print out true. Let's print out false and see what we get when we run the program. So if I run my program, it prints out the word true and it prints out the word false. Why? Because this is true. The Python word true is true. The Python word false is false. Now we can look at what type that is. Should have learned this from the first week. Whenever we do type, it tells us what type that is actually. So you have the different types in Python. You have integers, you have floating points, you have strings, you have lists, which we'll learn about later. We have dictionaries, which we'll learn about later. But you also have Booleans, meaning true or false. So let's print out what the type of this true is and print out this type of false. Let's save it. Let's run it. As you can see here, it tells you it's a bool. That means it's a Boolean value. It's either true or false. So we don't just have the word true and false. We can also have what we call conditionals, meaning we have really 6 different conditionals. We have that, which means if something is equal, this means if something is not equal. Then we have less than, greater than, less than or equal to, and greater than or equal to. Those are our 6 Boolean expressions that we can use. And I'll show you how to use them here in a second. But really, these are things, kind of going back to maybe middle school math or something, where you're trying to figure out if 2 values are the same, or if 2 values are equal to each other, if 2 values are not equal, if one value is less than the other, if one value is greater than the other, if a value is less than or equal to, and if a value is greater than or equal to. So I already showed you, if we just do this print true, actually, let's make these comments. Let's make all those comments. Let's put a little description. This means equal to. This means not equal to. This means less than. This is greater than, less than or equal to. And this is greater than or equal to. So if we just print true, like I showed you before, that's true. Well, let's start off with this equal to and see what happens. So I could put 3 equals 3. Take out that true. So what do we think is this going to print out? We're saying 3 is equal to 3. Is that true or false? Well, it turns out that's true, right? Let's run it. We can see it prints out true. It doesn't print out the number 3. I'm not asking it to print the number 3. I'm telling it to print whatever this is. And this is what we call a Boolean expression, meaning I'm using one of the conditionals here to compare two values. Here, I'm comparing the value 3, and I'm comparing it to the value 3. I'm saying 3 is equal to 3, and that is true. If I would put 4 here, that's obviously false because 3 equal to 4, that is false. So if I run that, it prints out that it is false, right? And so now we can use any of these comparisons we want. So let's keep going with the 3 and 4. Let's say it's not equal. Let's do the rest of them here. 3, start with 3 equals to 4, 3 not equals to 4. And we'll say less than, greater than, less than equal to, or greater than equal to. So if I'm printing out all these Boolean expressions, really what should I get printed out here? So this should be false because 3 equal to 4 is false. This should be true because 3 not equal to 4, that's true. This should be true. 3 less than 4, that's true. 3 greater than 4, well, that's false. 3 less than or equal to 4, that's true. And 3 greater than or equal to 4, that should be false. So when I run this, what I should have printed out is, false, true, true, false, true, false. And let's see if that's what we get. Let's check it. False, true, true, false, true, false, false, true, true, false, true, false. So that works out. And so you don't have to have it just with hard-coded numbers. When I say hard-coded, that means when you put specific values in here. That means I'm hard-coding the value 3. I'm hard-coding the value 4. Well, most of the time, that's not very useful, right? Because most of the time when we're running a program, we usually don't know the values ahead of time. For example, let's just get some input from the user. We'll just tell the user to input a number, and we'll save it as A. Then we're going to tell them to input another number, input another number. And then let's compare those numbers to each other. So what we're doing, we're getting a number from the user and storing it in the variable A. We're getting another number from the user, storing it in the variable B. And then we're going to run all those same comparisons. And now we don't know ahead of time if they're going to be true or false because we don't know what the values are yet. The user hasn't typed in the values. So let's save it and let's run this. Let's move this over here so we can see the code. There we go. So let's run this. Of course, enter a number. Let's just pick a number 1 and then input another number. Let's use 1 for both of them. And there's the result. And let's check it. So A is 1 and B is 1 because that's what I typed in. So we're saying 1 equals the 1. That's true. And that works out. 1 not equal to 1, that's false, and that checks out. 1 less than 1, well, that's false, checks out. 1 greater than 1 is false, and that checks out. And then 1 less than or equal to 1, that's true. And then 1 greater than or equal to 1, and that's also true, right? And so we can pick whatever numbers that we want. Let's pick 3, 4, 5, and 1, 2, 3. And there is the results of those comparisons, whether each one of those is true or false. Okay, so that's how our basic conditionals work. And we'll get to why that's important, why we need that. But right now, just know that you can compare two values using these conditionals. And it doesn't have to be numbers. Well, for example, I use ints, right? There's nothing wrong with it being float numbers. Let's save it and let's run that. And let's put in 2 floats. And it works for those as well. No problem. And does all the comparison. But it doesn't just have to be numbers. It could be a string. Well, input is already a string, so we don't need to make it a string. You should have learned last week that whenever you get input from the user, this input is always a string. And this is stuff from last week. So whenever I type in whatever at the keyboard, even if I type in 3.5, it treats 3.5 like a string. And so if I wanted it to be a float, I would have to do that right there. That means this input gets it as a string, and then this float converts it to a floating point number. The course material also shows you can use the eval. I personally am not a big fan of eval. You can use it. It's in the course materials. You're not going to lose points if you use it. But I will say if you ever get a programming job out there for a company, you'll actually never use eval. Eval is actually a security problem in Python code. So I prefer to see a float if you want it to be a float, or an int if you want it to be an integer. But if you use the eval, you won't lose any points. Right, but anyway, so let's go back and look at this. So if I don't do that, if I just leave it as input, it's going to be a string, right? And so I can do these same comparisons on strings. So let's run it now that these are strings. So let's put ASDF and the other one ASDF. Now let's look at it. So is ASDF equal to ASDF? It's true. Are they not equal? That's false. Is one less than or greater than the other? No, those are false. Is it less than or equal to? And that's true because they are equal. Or greater than or equal to? That's true because they are also equal. Well, what about this? ASDF and capital ASDF. What are we going to get for this? Because we can compare these strings, and actually these are two different strings because one is lowercase and one is capital. And in Python, there is a difference between uppercase and lowercase letters. So when we run this, we're saying, are those strings equal? And it's false. They are not equal. And that's because this is all lowercase and this is all uppercase. It would be the same thing if we use like a mixed case, like something like that. These are still not the same string because this has little a, little s, little d, capital F, and then you can see the string here. And so when we're comparing them, we're saying, are those strings equal? And it's false, they're not equal. Are the strings not equal to each other? That's true. There we go. And then is A less than B? Now this gets a little bit interesting when you're talking about strings. So go back to whatever grade in elementary school where you had to figure out really if one string was less than the other. So when you look at stuff in the dictionary, you know, A comes before B, right? So if I was just comparing A and B, A would be less than B because in a dictionary that, you know, the A would come first, right? Well, also, if we look at this A less than B, well, A is this string, B is this string. So now when we look at A less than B, it says it's false. And why is that? That's because in Python and really any programming language, capital letters come before lowercase letters. So when I'm comparing this capital A with this string that starts with the capital A, comparing it to this string that starts with the lowercase a, so when I say, you know, this string less than this string, it is false because this string does not come before this string because of little a and big A. Now, whenever I say if it's greater than, that's true right there. And that's because when you're comparing the uppercase and lowercase letters, they do have, one does come before the other. So if I just do, let's see, BBB, and I do AAA, now when I compare these, you know, we get it. The first two are equal to or not equal to, but then here's where it gets interesting. I'm saying, is the first string less than the second string? And that is false. And that's because the big letters come before the little letters. So you've got to be careful about that when you're comparing strings. The big letters come before the little letters. Okay, let's go back to these being, and that's how you compare strings. So let's do a quick example. Say input your name, and we'll call this a variable name, right? So we're going to say if your name is equal to Dan. Oh, well, we haven't done if statements yet. All right, we're going to do if statements towards the end. Well, actually here shortly, and then we'll look at that. I'm not going to do an example of if statement until I explain what an if statement is. All right, let's go back with input. Let's go back, input a number. There we go. So let's have the user input some integers again. There we go. So now we have integer A and integer B. All right. So we just looked at how you can compare individual ones, right? Print A is equal to B. Okay. Let's get a third one. We'll have numbers A, B, and C. Enter the last number. Okay. So we can print A is equal to B. Let's print A is equal to C. And then let's print B is equal to C. And you'll see where I'm going with this. Save it. Let's run it. And well, it says enter my name. Nope. Enter a number. Let's run it. So enter a number. Let's do 1. Let's do 2. And let's do 3. So we're getting false for all of them, right? Because we're saying, is A equal to B? We're comparing 1 and 2. You know, 1 equals 2 is false, 1 equals 3 is false, and 2 equals 3 is false. All right. What if we do 1, 1, 2? Well, now A is 1, B is 1, and C is 2. Right? And so we're saying, is 1 equal to 1? Well, that's true. Is 1 equal to 2? That's false. And is 1 equal to 2? That's false. That's what we're getting. So we can combine multiple of these expressions together. What do I mean by that? So I can say A equal to B, and that's true or false. I can also say and A equals to C. And what the and means, it means this must be true and this must be true. Okay? If this and this is true, then the whole thing is true. If either one of these are false, then the whole thing is not true. Let's look at an easier example. We could say print true and true. Let's comment out these for a minute. We're just going to print true and true. If we run that, it tells us it's true because both of them are true. If I say true and false, is that going to be true or false? The whole thing is going to be false because I'm saying true and false. Because they are both not true, the whole thing is false. And you see it's false. If I put false and false, it's still false because the whole thing is not true. With the and, it means everything has to be true. And it's false. So let's go back to true. You don't just have to have two, you can have three and true. True and true and true. All of them are true. So the whole thing is true. If any single one of them is false, then the whole thing is false. And there you go. Now there's an opposite of and it's called or. When we have or, it means if a single one of them is true, then the whole thing is true. So when I say true or true, is there at least one true in here? Yes, there is. So I get true. If I have true or false, is there at least one true? Yes, there is. It's right here. So it's still true. And of course, if I have false or false, is there a single one that is true? No, there is not. So the whole thing is false. And there it is. And so just like I'm using the words true and false here, you can compare the values just like we did earlier. So let's start out with the and. So I'm going to say A is equal to B and B is equal to C. Let's save and run it. So let's do 2, 2, 2. And that gives us true. Why? Because A is 2, B is 2, and C is 2. So I'm saying 2 equals to 2. That's true. And 2 equals to 2. That's also true. Let's do something a little different. Let's do B is less than C. Now let's do this. 2, 2, 2. It gives us false. And why is that? Because A is 2, B is 2, C is 2. We're saying if 2 is equal to 2, that is true. And 2 is less than 2, well, that's false. So since both of them are not true, then it's false. But, you know, if we change that to an or and run it, we get true now. And that's because this is true or this is false. But since it's an or and at least one of them is true, then it makes the whole thing true. So let's make C a string. So C is just now a string. So let's compare, let's say this is your name, right? We're going to compare C is equal to my name, Dan. We'll have A be your age. Input your age. It's just a little example. So A is going to be your age and C is your name. So I'm going to figure out if I am me, and if I'm below a certain age, say 40, right? So let's run this. Let's see what this looks like. Enter your age. Let's say if I put 39 and I put my name is Dan, what am I going to get? I'm going to get true. And that's because my age is less than 40. That's true. Or my name is Dan. Actually, I meant for that to be and. Still going to get true out of it. I'll show you. Because age is less than 40 and the name I input was Dan. So let's say age is 50, name is still Dan. Well, it's false now because this age is not less than 40. The name is still Dan, but both of these are not true. Of course, if I change it to or, I can put my age is 50 and I'm Dan, it's going to be true because this part is true. If I put my age is less, my name is not Dan, it's still going to be true because this part was true. And then, of course, if neither one of them is true, it's going to give me false. So that's how you can use the or and the and with these Boolean expressions. So now the good thing is, what use is this? If comparing two values and figuring out if it's true or false, how does that help us? Well, we have what we call conditional execution. That means I only want to execute some code if something is true or false. So I've already shown you how to do comparisons if something is true or false. Well, now let's execute some code only if something is true. Here's how we can do this. So let's just make up something to print out if somebody is old or young. Okay, so we'll have a variable called age. We'll let the user type in their age. Now, I want to print out young if they're young, and I'm going to have it print out old if they're not old. Now, I don't know how old anybody is in the class, so don't get offended if I put your age in the old or young category. But I'm just going to say 50 years old. If you're 50 or greater, I'm going to call you old. If you're less than that, I'm going to call you young. And here's what that looks like. I can say if your age is greater than or equal to 50, and then in Python we have a colon, and then we tab over. Let me show you what it looks like. You are old. Print. Ha ha ha. So what's going to happen here? So first, we're going to let the user type in your age. And now here we have what we call a conditional expression. Just like we've been seeing before, the greater than or equal to, less than or equal to, the equals, the not equals, and so on and so forth. Well, here I'm going to compare your age to the number 50. Here I'm saying if this is true, this is either going to be true or it's going to be false. Here I'm saying if this is true, then I want to execute this code. Notice a couple things here. I have a colon after this conditional check. It's just the way Python works. If you're doing a conditional check with this if statement, you put a colon at the end. And then any code that you want to execute, you have to tab it over one space. You can't press the space bar. That doesn't work. It has to be a tab character. Python is very, very specific in particular about it having to be a tab. The end. And then here we'll print it in. So whenever it does this check, if this is true, any code that is tabbed in, it will execute that code. If this is false, it will skip any of the tabbed in code. And then down here, since we don't have tabbed in code anymore, this kind of marks the end of this conditional execution. So the tabbed in code is part of the conditional execution, meaning it only runs if this is true. And then afterwards, it resumes with code that is not tabbed in. So let's see what this looks like when we run it. So when I run it, if I say my age is 55, that is going to be true, right? 55 greater than or equal to 50 is true. So this is the code it's going to execute. And then it'll still execute this because it's no longer indented in. It's no longer tabbed in. So let's run it. And it says, you're old, ha, 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 the end, right? And that's because it executed this tabbed in code. Well, let's make this false. Let's say I'm 33. So 33 greater than or equal to 50, that is false. So you are not going to see this printed out. It is going to skip over this code. And that's because this is false. Let's run it. And as you can see, it does not print out that you're old. It just prints out the end, just showing that it got here to this next section of code and it skipped over this. Now, if I wanted to print you are old, maybe I wanted to print you are young. So here I can say if the age is less than 50, print you are young, right? So this is just having two of these checks in a row. Here I'm saying if the age is greater than 50, you're old, it prints this out. And then here I'm just doing another check. If the age is less than 50, then I'm going to say you are young. Save it and let's run it. Of course, if we put the over the age, you're old, ha, 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 the end, just like before. Now, if I put a less age, it's going to say you are young. So these if statements are how you control what parts of your code are being executed. For example, just like in our example here, if your age is old, we want to do one thing. If your age is young, we want to do another thing. And thinking about this as like a real world example, what's a real world example of this? Well, let's say it's temperature. Let's say we're putting in the temperature. And if it's greater than we'll work with Fahrenheit here. Let's say 80 degrees. If it's greater than or equal to 80 degrees, you want to put on shorts. If it's less than 80 degrees, you're going to put on pants, right? So this is a way you can check the temperature and you can have the program tell you whether you should be putting on shorts or pants. If I run it, it says input the age. Let's say input today's temperature. So input today's temperature. Let's say today is 66 degrees. Age. I'm using the variable age, but age doesn't exist. I changed it into temperature. There we go. So today's temperature is 66 degrees. So it's telling me I should put on some pants, right? And of course, if I say the temperature is 88 degrees, it's going to tell me to put on some shorts. So, that's kind of a real world-ish example of why you need, these checks. Let's do one more. We'll say gas. Input how much gas in car. You know, how many gallons of gas do you have in your car? And if the gas is less than 3 gallons, you better stop for gas. If the gas is greater than or equal to 3 gallons, keep driving. Maybe, the little light in your car that lights up when you're low on gas, this is what it's doing. Let's run this. And let's say we have 5 gallons of gas in the car, we can keep on driving. If we have 2 gallons of gas in the car, we need to stop for gas. This kind of programming, like I said, is what controls the little, tank almost empty gas light that lights up inside your car when you're low on gas. Somebody wrote some code that figured out how much gas is in your tank, and then, it doesn't print it out, but it turns on a little light in your dashboard that says you need to stop for gas. Right? And so this is the kind of code that's running to make that happen, these if statements. So there's a couple variations on the if statements. So here, I'm saying if the gas is less than 3, and then later, if the gas is greater than or equal to 3. Well, there's another way I can do this, and it's called an else statement. It looks like this. So like I said at first, is this true or false? If this is true, I want to execute this code. If this is false, I skip this code, right? Well, the else kind of works in conjunction with the if. What happens is, if this is true, this code gets executed. If this is false, the else code gets executed. So let's rerun our example. So if I put in 2 gallons, it says I need to stop for gas because 2 less than 3, that is true. So it ran this code. And then it skips this because this only happens if it's false. But it was true, so that's what happens. Now, if we make it false, let's say I have 5 gallons of gas, it says to keep driving. Why? It says 5 less than 3, that is false. And so if it is false, it does the else statement. It skips this one and does the else statement. So just like we did for gas, we can do it for the age. Input age. If your age is less than 30, you are young. Else, you are old. So of course, if I put in, I'm 25, it prints out you were young. Because that was true, it does this. And of course, if that is not true, it says you're old. Of course, if we put in exactly 30, which one is it going to be if I put in exactly 30? It's going to be the else statement, you're old, because I said 30 less than 30. That's false. It's equal to, but it's not less than. So since this is false, I skip this one and I execute the else code here. So that's our conditional execution. All right. So now the last part of what's actually in your material for the week is about test reports. We'll cover that, then we'll do the assignment, and then we'll have questions and answers. So test report. I've done this class. This is probably about the 15th or so time I've done this class. Every single time, people just don't do the test reports. Either they don't do the test report or they don't do the test report correctly. So I'm going to show you what a test report looks like using our examples here. All right. So instead of just you are young, I'm just going to print young and I'm going to print old. Okay. So let's say this is my program. All right. Delete all this stuff out of here. This is my complete program, right? I have an age and then my program is either going to print out young or it's going to print out old, right? And this is my input to the program. My input to the program is whatever I type in at the keyboard. You know, it's going to be some number. It's going to be 5, 10, 20, 90, 32, you know, whatever the number is, that is the input to my keyboard. And this print young or print old, that is the output for my program. So when I run it, whenever I input an age, 33 is my input and old is my output. My program did some kind of computation and it gave me an answer in return, right? So let's look what a test report for this would look like. I think sheets. Do I have sheets on here? Give me a second while this starts. Oops, that's not what I meant to do. What I meant to do. All right, I'll just do it in Excel. Let me open up Excel on my computer. It's easy to do it in a spreadsheet. You can do it in a Word document with a table or something like that. That's fine. All right. Let me share a different part of my screen. Screen 1. There we go. You should see that. Oops. My spreadsheet. All right. You should also be able to see my spreadsheet right now. Can someone tell me if you see the spreadsheet? I think you should be able to. All right. Okay. Yep. All right. So you see my spreadsheet. Like I said, the test reports are easy to do in a spreadsheet. You don't have to do them in a spreadsheet. You can just make a table in a Word document. That works just fine. No problem. So your spreadsheet, excuse me, your test report needs 5 columns. The 5 columns is the test case number. The next column is the input. The next column is the expected output. Then the next column is the actual output. And then this is the result. Let me spread these out a little bit. Increase the, yeah, there we go. Increase the font size. There we go. So this is what our test report starts out looking like. Oops. Like that color. All right. So in the test case column, it's really just a numbered list of your test cases. And for your test reports, at minimum, you should probably be doing 5 test cases. So the test cases just number 1 through 5. Now, the input is what input are you giving to your program? And it's really program specific. And if we look at our example here, you know, I'm talking about age is the input, right? So for my inputs, I need to put different ages for these different test cases. So let's say I input 10, 20, 30, 40, and 50. So for each test case, that's going to be the age that is going to be the input to my program. And now I need to think about what is my expected output. So like we said, the output is either young or old. So I need to think for this input, if I input 10 for the age, what do I expect my program to tell me, right? Now, it is extremely important that you use your brain to logically think about what this output is going to be. Okay. You should not run your program and see what your program tells you. That comes later, but you need to think about what the answer should be. So in my program, I'm saying if the age is less than 30, it should be young, right? That's what my program is doing. So if I put in 10 for the age, is it going to tell me young or old? Well, I'm expecting it to tell me young. If I put in 20, I'm expecting it to tell me young. If I put in 30, 40, or 50, I'm expecting it to tell me old. Right? Actually, let's do a little bit of a better example. I thought of a more realistic example. Let's do, I actually like this one a lot better. Let's compute an area. Should remember length. You should remember this from like middle school, maybe high school, I don't know. Length, enter length, input width. And to compute the area, it's the length times the width, right? And then now we're just going to print the area. I like this example a lot better because we're actually doing some kind of computation. I like doing computations. Right. So now let's revisit this. We can still have our test cases. Right. But now our input is actually two numbers, right? I'm asking for two numbers here. I'm asking for the length and the width. So for the input, there's actually going to be two numbers. Let's say I use 1 and 2. I use 4 and 3. And these can be really whatever you want them to be. 3 and 3, 10 and 3, 3 and 0, and 11 and 11. Okay. So I know my program is computing the area and then it prints the area. So this printed area is what the output is, right? The input is this length and width, and the output is the computed area. Okay. So not using your program, like I said, it's extremely important. You don't use your program. You need to use your brain to figure out what the expected output is. You can use a calculator if you want to. That's fine to use a calculator. But the key is do not use your program. And you'll see why here shortly. But let's figure it out. So if this is my input, what's the expected output? The expected output is 2, right? Because the program is really just the numbers multiplied. So what's 4 times 3? That's 12. 10 times 3 is 30. 3 times 0 is 0. 11 times 11 is 121. That is what the expected output of my program is. So now we need to do the actual output. To get the actual output, here is where we actually do run our program, and we will record what our program tells us the answer is. So let's run it. Let's run it with, make this a little bit smaller so we can see both of them at the same time. There we go. There's our spreadsheet. Here's our program. All right, there we go. Well, we can almost see all of it. All right, that's good enough. Okay, so the input is 1 and 2. So let's run the program with 1 and 2. It tells us the answer is 2. So the actual output is 2. Now for result, you compare these. Are these the same thing? Is the actual output the same thing as my expected output? And the answer is yes. That means it passes. For this test case, my program works correctly. Well, let's try it for 4 and 3. Let's run it. Oops. There we go. Let's run it with 4 and 3. It tells us the answer is 12. I put 12 here. Are those two the same thing? They are. So it passes. let's do 10 and 3. 10 and 3 tells me the answer is 30. It passes because they're the same thing. Let's do 3 and 0. 3 and 0. It tells me the answer is 0. That's true. And now let's do 11 and 11. And it tells me the answer is 121. And so now that is true. And now my test cases are complete because, excuse me, my test report is complete. And that's because the result is true for all of them, meaning for all of these different inputs, what I expected the answer to be is what my program actually told me the answer is. So why is this important? It's important because you're trying to catch bugs in your program. Okay. And what do I mean by bugs? Let's say I made a mistake in my program. Let's say instead of multiplying, I accidentally had a bug and I just added them together, right? So this is a bug, right? This is no longer computing the area, right? It's not computing the area. To illustrate the case, let's make this 2 by 2. This will be good. Okay, let's delete all this. Let's delete all this. So let's say we kept all of these same test cases, the same inputs. But now for our program, let's say our program is still supposed to compute the area. So for my expected output, it's 4, 12, 30, 0, 121. That's what I'm expecting the area to be. But I have a bug in my program. I computed the area incorrectly because the area is not an addition. It should be a multiplication. That's the correct way. But I had a bug and I just did addition instead. Okay. So now we have our test cases set up. We have our expected output. Now let's see what the actual output is. So when I run the program, when I put 2 and 2, it tells me the answer is 4. Well, that's actually true. Does that mean my program is working correctly? And the answer is no, because we need to run all of our test cases. We just got lucky that it ended up being the same answer. Even though we have a bug in our program, we just got lucky that they're both true. Well, let's do the next test case, 4 and 3. It tells me the answer is 7. So I put 7 here, but now we have a problem. That result is false. Those two are not the same answer. I expected my program to tell me 12, but my program told me 7. So the result is false. So that tells me something is wrong with my program. Let's go ahead and run through the rest of them real quick. 10 and 3, it tells me the answer is 13. That's false. 3 and 0, it tells me the answer is 3. That's false. And 11 and 11, it tells me the answer is 22, and that's false. So what have I discovered here? I have discovered that there is a bug in my program, and I know there's a bug because the answer I expected is not the answer it gave me. It just so happened to be in one of the cases, but just because one of the cases passes does not mean the rest of them passed. This one worked out, but the rest of them did not work. There's a bug in my program. So I need to go find the bug in my program. So I go back to my program, I review it, and I find it. Like, oh, here where I computed the area, I did it incorrectly. It's supposed to be multiplication, not addition. I see your question in the chat. I'll get to it here in a second. So, I noticed there's a bug in my program. I fixed the bug in my program. So now that I fixed the bug in my program, or at least I think I have fixed the bug in my program, I need to delete those back out of there because those are no longer valid. The actual output is no longer valid because I changed my program, right? So now let's run our test cases again. Now that we think we have fixed the bug, let's run it with 2 and 2. I'm just going to do them all in a row real fast. 4 and 3, 10 and 3, 3 and 0, and 11 and 11. So it told me the answers were 4, 12, 30. It says it was 4, 12, 30, 0, 121. That's what my program told me the output was for each of the calculations. And the result for each of those is now true. My program is now working correctly. So this is a complete test report, and it's telling me that for all of these different inputs, my program is working correctly. So it is extremely likely that my program doesn't have a bug. It's not always 100% guarantee, but it means it is extremely likely that my program functions correctly and I don't have a bug. And so the question in the, this actually gets to both your questions. So the question in the chat says, do you always run all the inputs even though you realize there is a bug after the second and third attempts? And then, and the answer is no, you don't have to. And I'll show an example of that here shortly. And the second question is, if we have a bad test report, would you like us to submit that as well as a corrected one? And the answer is no. And I'm going to answer both of the, I'm going to kind of show both of those at the same time. All right. So let's put the bug back in our program. So we'll do addition, I'm putting the bug back in the program, right? So I made a change to my program. This actual output and everything is no longer the case, right? I have to run my test report again. So let's run it. All right, let's run my program. I put a 2 and a 2 as my input. It tells me the answer is 4. That result is true, right? Let's run the next one with inputs of 4 and 3. It tells me the answer is 7. Well, that's false. Well, really, you can stop right there. You don't need to go through the rest of the test cases. And the reason being is already on test case number 2, you've already realized there's a bug. There's something wrong with your code. So really, as soon as you get this first false, you can really stop right there because you need to go find out what's wrong with your program. So I don't need to go through and do the rest of them because I've already realized there's a problem. I need to find the problem. I need to correct the problem. And once I correct the problem, I have to throw out the actual output and the results. Those are no longer valid. I changed my code. I fixed what I think is the problem. And so I run my test cases again. So the answer is once you get a false here in the result, you can stop, go back and fix your program. And to answer Christy's question is no, if it still had the bug, it looks like this. If it still had the bug, it looked like that. You don't need to submit this. And actually, you should not submit this. And you should not submit your code like this because there's something wrong with it. So as soon as you get the first false, stop right there, fix your program, and then do your test report over again. So you don't need to submit this. You really shouldn't be submitting anything unless all of those turn out to be true. Because if you submit code that has some falses in here, then I'm going to know there's something wrong with your code and you didn't do it correctly. So at the end of the day, what you should submit is a test report where all of the results are true and it's on the code that you submit. Now, that's all there is to a test report. But now I'm going to show you how you can mess up your test report. And if you do what I'm getting ready to show you on your test report, I will just give you a 0 for your test report, period. No questions asked. No matter what else you have in your test report, if you do this, what I'm getting ready to show, you will just get a 0 for your test report. Before I show that, let's talk about what is the purpose of a test report. We can see here is that, when this was a plus, the purpose of a test report is to find a bug in your code, right? I had this bug in my code and I ran this test report and this told me something's wrong. There is a bug in my code, right? That is the entire purpose of a test report, is to find a bug in my code. Okay. So let's say I wanted to be lazy, and really what this is being lazy, to be honest. So let's say I made up this test report. Let's say I still have this bug in my code. All right, I still have the bug in my code. But let's say I was being too lazy to manually calculate the expected output. Okay, I just didn't want to go through the problem of figuring it out. I mean, for a simple program like this, it's only like 4 or 5 lines long. It's easy to figure out the expected output for this. But imagine you had a more complicated program that did a lot more complicated computations. It wouldn't be just as simple as to figure out the expected output. So let's say you were being lazy and you didn't want to figure out, using your own brain, you didn't want to figure out what the expected output would be. You're going to be a little bit arrogant and you're going to think, well, there's no way my program has a bug in it. I did everything right. There's no way it has a bug in it. Well, let's say we treat it like that. So you don't fill out the expected output. You just run your program. And let's do all the inputs again. 2 and 2, 4 and 3. You just do this right here. 10 and 3, 3 and 0. And what was it? 11 and 11. So you're a little bit arrogant and you think there's no way my program is wrong. So I'm going to take the actual output, which is 4, 7, 13, 3, 22. And I'm just going to copy it over to the expected output. That's what I'm going to do, because I didn't want to bother figuring this out. I know my program is right. Being sarcastic there. There's no way it can be wrong. And what do you know? All of the test results are true. What is the mistake that I've made here? The mistake is all of my test cases say true, and yet there is a bug in my program. I did the wrong computation, but all of my test cases say true, so I think my program is working correctly. And really, it's because I was just lazy. I didn't figure this out on my own. I just looked at the output from the program and just copied it over. So if you do that, you will get a 0 for the test report portion of your program. Now, how can I tell if you've done that or not? How do I know if you've done that or not? Well, if I see this right here, I know that's what you've done. How do I know that? Because when I look at your code, whenever I grade your actual code, I can look at it and I can see that you made a bug, right? I know this is a bug in your code. So I can look at your test report and I know this isn't right, because I can look at your input. It's supposed to compute the area. So I do the expected output. I'm saying, okay, 4 times 3 is 12, but you put 7. That's not right. 10 times 3 is 30, but you put 13. That's not right. So whenever I look at this expected output and you have not done the correct computation, and it matches what your actual output is, then I know this is what you've done. I know that you haven't done the work to figure that out, and all you've done is just copy your actual output. That will get you a 0, at least for the test report portion of your assignment. So I hope this clears up test reports. Please follow this format. Like I said, a spreadsheet works good for it. You can do a table in a Word document, whatever works for you, it's fine. But it needs to be in a table-like format. It needs all 5 of these columns. And then I've shown you how to figure out what goes in those columns. All right. That's all of the material for this week. I'm going to spend maybe about 5 or 6 minutes doing the assignment. And then we will have any questions and answers you may have. Okay. So your assignment is about, let me bring it up to make sure I'm saying the right thing here. Yeah, so you need to write a program that figures out how much you're going to charge to clean somebody's house, right? And the amount that you're going to charge somebody is based on, how many rooms they have, if they have a little bit of rooms or if they have a lot of rooms, right? And then, what kind of cleaning you're doing. Are they just cleaning the floors, the windows, etc., right? So you need to use some if statements, because let's break it down. For the first part, the charge is based on how many rooms you have, if you have a lot of rooms or a little bit of rooms. So your code needs to figure out, are there a lot of rooms or are there few rooms? So that's an if statement. So let's say you use 5. If there is less than 5 rooms, then you charge a little bit of money. If there are more than 5 rooms, you charge a lot of money. That's an if-else statement, like we did earlier in the lecture. So let's do an example a little bit like this. So we're going to do it for movie tickets. Let's say we're going to have the cost of a movie ticket starts out to be 0. And so the cost of a movie ticket depends on how old you are and if it's a 2D or 3D movie. So let me just put it in words. If you are young, then the cost is $5. If you are old, then the cost is $3. If you are middle-aged, then the cost is $10. You get like the child discount or the senior citizen discount, right? Also, if the movie is 3D, then it's an extra $2, right? So let's say that's how I want to figure out how much money I want to charge you for a movie ticket. All right. So the cost starts out being 0 because I don't know how old you are yet. I don't know if it's 3D or 2D yet. So far the cost is 0. But now we need to figure out if you're young. So we need to get your age. Input, enter your age. So now I can say if the age is less than 7. Let's say that's the child. If you're less than 7, then you're young. So if the age is less than 7, then the cost is going to be $5. Here we can use another concept. I didn't cover this earlier, I forgot, but we can say L if the age is greater than 60, the cost is $3. I'll explain the LF. I'll explain this here in a second. The cost is $10. So what's happening here? So I'm having the user type in their age. Let's make it a little bit bigger. Yeah, I'm having the user type in their age. If their age is less than 7, then the cost is $5. And here, LF, what it stands for, else if, it just means I'm going to do another comparison. It will only do that comparison if this is false. So if this is true, this code gets executed and the rest of it gets skipped. If this is false, it skips this part and it goes here. And here it's just doing another check. If this is true, that gets executed and the rest of it is skipped. If this is false, that gets skipped and the rest of it gets executed. So here I'm figuring out how much to charge you based on how old you are. So if you are young, so if you are less than 7, your ticket costs $5. If you are old, the ticket is $3. So I'm saying if your age is over 60, then the cost is $3. And then else, if neither one of those is true, if that is false, it does this. If this is false, it just does the else. So this is saying if I'm in that middle age, then my cost is $10. So far, let's just print out the cost. Here in a second, we're going to do that check for a 3D movie. But so far, let's check if this is working. So if I put in my age is 2, my ticket is $5. That's right. If I put in 7, my ticket is $10. Because, you know, I said if you're less than 7, when I put in you are 7, so it gets down to my cost is $10 because 7 less than 7 is false. 7 greater than 60 is false. So it ends up at that else statement. And then if I put 66, my ticket is $3 because, you know, I fall in this category. All right. So last part of it is, you know, if the movie is 3D, then I'm going to charge $2 more. Well, let's check if the movie is 3D. Is 3D, it's the name of my variable. Input, enter 2D or 3D. So now I'm going to say if that variable is equal to 3D, then my cost is equal to the cost plus $2 more. Right? So, you know, we already talked about this top part. Make that, there we go, fit it all on there. We already talked about this, checking the age, but now we're going to have the user type in either 2D or 3D. If they type in 3D, we're just going to add $2 more onto the cost. And that fits that description right there. If the movie is 3D, then it's an extra $2. Let's run it, see if it works. So my age is 3. It's a 3D movie. So the cost is $7. And is that correct? Well, here is really where you should be using a test report to make sure it's correct. I've already shown you the test report, so I'm not going to go back through the test report again. But let's just look at it and figure out if that's right. So my age is 3. So that's the initial cost of $5. And it is a 3D movie, so I added $2 more. So 5 plus 2 is 7. And that's right, it is $7. So if my age is 3 and I put in a 2D movie, the cost is $5. And that's because, you know, the initial cost is $5 because the age is less than 7. But this was not true. This was false. Actually, you don't need the braces around there. So it did not add the $2 back onto it. Let's run it one more time. My age is 44. It's a 3D movie, so the cost is $12. Is that right? Well, the age 44 gets us right here. And the 3D movie adds $2 more to it. So I get 12, and it tells me that's the answer. So it's right. So really, this is really about all you need to do for your assignment. Obviously, it's not about movies. It's not about ages. It's not about 2D or 3D movie, but it's about how many rooms are in the house and what kind of cleaning you're doing. Are you cleaning the bathrooms? Are you cleaning the floors, et cetera, et cetera? And you have to base your costs on how many rooms and what type of cleaning you're doing. Okay, that takes me to the end of everything that I'm going to talk about today. So I'll go ahead and open it up for any questions you have. It can be about this week's material, last week's material, the assignment, or really any other Python question you may have. So the floor is open for you to ask questions. So a question I have is, if we have worked ahead, are we allowed to use material from later weeks, or should we avoid doing that? You can feel free to use material from later weeks. Really, you can use any Python code you want. You can use stuff that we never cover in class. That's fine. Here's the warning I will give you, though. And it applies to advanced material. This also kind of applies to doing things not covered in the assignment. So if you want to use advanced Python code, or if you want to make your program have additional capabilities, that's fine. I have no problem with that. However, if your advanced code is incorrect, or if your additional functionality is incorrect, you will lose points. So let's say we have our example here. I did this movie ticket thing. If you want to also add in something here you want to compute some snacks, right? You want to charge some more money if they want to buy some popcorn. You can do that, but if your code is wrong and gives you a wrong answer for that popcorn, then you're going to lose points. So it doesn't make much sense to do extra work. Well, I guess that goes more into doing extra work that you can. I wouldn't advise it because you can lose points if you do extra work. But I mean, for advanced Python code, if you want to use something that's covered later in the class, I have no problems with that. You just have to make sure you actually know what you're doing and do it correctly, because if you use the advanced code incorrectly, you'll end up losing points. Any other questions? All right, doesn't look like anything else. I'll go ahead and wrap this up. As I said, the video was recorded and I will get it uploaded and a link sent out shortly. If you need any help or assistance, please reach out to me by email. I don't know you need help unless you let me know. All right, everyone have a good rest of your weekend.